Alright, section 5.2, 0 and negative exponents. Today we're going to be dealing with numbers to the power of 0 or with negative integers as their exponents. So we'll learn how to simplify expressions involving the exponent 0 and negative integral exponents. The definition of power states that any integer can be used as an exponent, not just a positive integer. So to make this work, we have to have a couple of things, mainly that anything to the 0th power equals 1. Well, anything separate 0. A to the m times a to the 0. If you remember the law of exponents, if you multiply exponents with the same base, you have to add the exponents together. So we have a to the m plus 0, which of course is a to the m. This makes a to the 0 equal to 1. Likewise, a to the 0 will have to equal a to the m over a to the m. This is equal to a to the m minus m, or 1. So here's our rule. If n is a positive integer and a is not equal to 0, then a to the 0 equal 1, a to the negative n equals 1 over a to the n. So keep in mind that any number to a negative exponent, if a is positive, the number is still going to be positive. You're just basically transferring the number to the denominator of a fraction with 1. It's a reciprocal type function. So a to the negative n is 1 over a to the n. Alright, example 1. 2 to the negative 2 times 3 squared. Now remember, the negative exponent does not mean a negative number. It means the reciprocal of the positive exponent. So 2 to the negative 2 is equal to 1 over 2 squared times 3 squared. So 1 over 2 squared is 1 over 4. 3 squared is 9. So the answer to number 1 is 9/4. Remember, this is not a negative number. It is a reciprocal of the number with a positive exponent. Let's go to number 2. Alright, simplify. Negative 2/3 quantity to the negative 2 power. Remember, with a negative exponent, you want to take a reciprocal of the positive. So it's 1 over negative 2/3 squared, which becomes 1 over 4/9, which is 9 over 4. Negative 2/3 squared is simply 4/9. Negative squared is 1, 2 squared is 4, 3 squared is 9. So that's one way to do it, and I'll show you a different way maybe in class or maybe later in these notes. Example 3, 1/2 to the negative half times 5/7 all to the negative 2 power. To the negative 2 power. So what you want to do is start working from the inside out. Do the parentheses first, then save this for last, because you're going to need to do the parentheses in the beginning anyway. So 1/2 to the negative 2 is simply 1 over 1/2 squared times 5/7. If you multiply that out, you get 1 over 1/4. 1 over 1/4 is 1 divided by 1/4, or 4. And again, you're going to have to, if you are not comfortable dividing fractions, you might have to write out 1 times the reciprocal of this fraction, which is 4 in this case. 4 times 5/7, you multiply the numerators together, you get 20 over 7 to the negative 2 power. Again, this is a reciprocal of the positive, so this is 1 over 20 squared, 20 over 7 squared. That's equal to 1 over 449. And with the reciprocal of a fraction, you just flip the fraction upside down. So your answer is 49 over 400. Now what you could do is you could see that negative 27 squared, you could take this and just do one of these things. You could flip it over, 7 over 20 squared. And that might work sometimes. I don't know if I do this all the time because I don't want you to get in the habit of doing it, but sometimes this works okay. So you could just simply flip the fraction upside down and change the exponent to a positive. But be careful when you do that, because sometimes funny things can happen when you're not careful. Simplifying with exponents. This means that in your final answer you do not have any negative or zero exponents in the solution. So the domains of all variables in any algebraic expression are automatically restricted so that the denominators of fractions and bases of powers with negative and zero exponents will not be zero. So what you want to do is make sure all the negative exponents are positive, which means if you have something like x to the negative 2, you rewrite that as 1 over x squared. If you have x to the 0, you just convert that to a 1. Let's see how this works. Example 4. Express in simplest form without using any negative exponents. So 458 times 10 to the negative fourth. So the 10 to the negative fourth we have to re-express as a positive exponent, which means we have to take the reciprocal of 10 to the negative fourth. So we get 458 times 10 over 4. Now you combine that into one fraction. Expand the 10 over 4 to 10,000. Now you can reduce this into a simpler fraction, or you can simply rewrite this as 0.0458. So what we did here is make sure you get rid of the negative exponent. You take this negative exponent, you move it downstairs so that it's positive. So you do not want any you don't want any negative exponents in your answer. So make sure you do what it takes to get rid of the negative exponent. Number 5, express in simplest form without using any negative exponents. So here we go. Now, this looks like a bit of a mess, but it's really not that bad. So what you'll want to do is use the definitions that we used yesterday with the quotients of monomials. Let's break this down. The 6 over negative 1 is a 6 to the negative 1 power is equal to 1 over 6. It's merely 1 over 6 to the first power. So 5 to the 0, that becomes 1, so we don't have to worry about that anymore. Remember, when you are dividing fractions with the same base and different exponents, you merely subtract. So 2 minus negative 1 and 3 minus negative 2. So let's see where this leads us. 1/6 times x cubed z to the 5th. So again, all we did was subtract the exponents here, 2 minus negative 1. And after you do enough of these, you'll get used to it, so you don't actually have to write this down every time. You'll see the patterns very quickly. And let's simplify this by putting it all over into one fraction. So this gives us x cubed z to the 5th all over 6. So notice how our answer does not have any negative exponents, nor does it have anything to the 0th power. And that's what we want. In simplest form, no negative exponents, no 0 exponents. Number 6, express in simplest form without using any negative exponents. 4m to the negative 2 over n times m cubed over 3n squared to the negative 1. So the first thing you can do is you can move the m to the negative 2 downstairs. M to the negative 2 is equal to 1 over m squared. So I just moved that downstairs. The other thing you can do is anything to the negative 1 power is merely the reciprocal, which in this case means you just turn the fraction upside down. So make the numerator the denominator and the denominator the numerator. So that's all I did. So we're left with 4 over m squared n times 3n squared over m cubed. Now when we multiply across, you just multiply as you multiplied before. 4 times 3 is 12. You're left with the n squared. M squared times n cubed. Remember, by multiplying exponents to the same base, you are adding the exponents together, so you get m to the 5th times n. Now you can see what you can do with the exponents. The n squared and the n divides into the n squared and leaves you a single n. And you're left with 12n over m to the 5th. Number 7. Now we're going to express without using fractions. So we want to convert 3 over 100,000 to a fraction to an exponent without fractions. So let's go ahead and do this. 100,000 is equal to 10 to the 5th power. Now we don't want fractions, so this is the case where we're not simplifying, but we're trying to express it without a fraction, which means we have to take the 10 to the 5th and make it in a negative exponent. So 10 to the 5th in the denominator is equal to 10 to the negative 5th in the numerator. So the final answer for number 7 is 3 times 10 to the negative 5th. So when it says express without using fractions, we have to basically unsimplify the expression. Number 8, 2a over t cubed over b. So what you can do is see that the t cubed and the b on the bottom can be re-expressed with negative exponents. So t cubed on the bottom is equal to t to the negative 3. So you can re-express as a t to the negative 3. Also, 1 over b, well, that's the same as 1 over b to the 1. So again, to express that as a negative exponent, you will just change that into a b to the negative 1. So we have a t to the negative 3, a b to the negative 1. We put that in the answer, and you get 2at to the negative 3 times b to the negative 1. So remember, all the exponents in the denominator are negative exponents when you remove it from the fraction. Number 9, 8x squared y over 8x squared y over xy cubed. So before you do anything, let's simplify the expression. The x squared and the x simplify to an x on the top. The y and the y cubed, that leaves us a y squared on the bottom, because again, if you learned yesterday, if you have a fraction with an exponent bigger in the denominator than the numerator, you will subtract 3 from 1, so you get 8x over y squared. The only thing we need to convert to a negative exponent is this y squared. Y over y squared is equal to y to the negative 2, so your answer is 8xy to the negative 2. So this section is not that complicated, just a couple concepts, but don't let the negative exponents trip you up. Remember, they're not negative numbers, they're merely positive numbers. They are reciprocal of the positive exponent. So we'll do some practice questions and homework assignments on the next day in class. If you have any questions until then, please ask me before.